Today we're going to be talking about sequences. So for this section we need to know a couple of terms. Okay, first of all, a sequence is going to be a set of numbers in a particular order or pattern. So for example, the numbers 2, 4, 6, 8, ... that would be a sequence because it is the list has a particular pattern. It's going up by twos. The term is going to be each number in a sequence. So an example of a term from our first sequence might be the number 2. Alright, a finite sequence is going to be one that has a limited number of terms. So we're going to have 2, 4, 6, 8, and then maybe we stop at 10. And that's it, that's done. An infinite sequence is going to be one that continues with no end. So maybe one like that would be this first sequence that I wrote down, where the ... means we're going on forever and ever and ever. Alright, there are two types of sequences that we need to look at. The arithmetic sequence and the geometric sequence. The arithmetic sequence is a sequence in which a constant is added to each previous term. So if we look at our sequences above that we wrote down for examples, you'll notice that these are arithmetic sequences, and that is because we're adding a number each time as we go. Here we're adding 2, and that is the common difference. The common difference is whatever we're adding to in the arithmetic sequence. So it's our constant. So in this case, it's 2. A geometric sequence is going to be one in which each term is being multiplied by a non-zero constant. So for example, instead of 2, 4, 6, 8, we might have 2, 4, 8, 16, 32, etc. Now this one is geometric because instead of adding something each time, we're multiplying. And in this case, our common ratio, or what we're multiplying each time, is going to be 2. Alright, let's go ahead and look at a couple examples. For our first example, we want to determine whether each sequence is arithmetic, geometric, or neither. So as we look at these sequences, we want to ask ourselves, are we adding, subtracting, multiplying, or dividing? And when we're multiplying or dividing, we're really just multiplying by the reciprocal of something. And when we're adding, when we're subtracting, we're really adding a negative number. So if we look at the first one, we're going up. So if it was arithmetic, we're adding something. So let's look, and what you want to do to test if it's arithmetic is you take the last number and you subtract the second to last number, and then you take the second to last number and subtract the next previous term. And if you get the same number, then you know that it's going to be arithmetic. So let's go ahead and compute that. 54 minus 36 is 8. 36, let's write that down. 36 minus 24 is 12. Those aren't the same, so it doesn't look like it's going to be arithmetic. So let's go ahead and try geometric. To test if it's geometric, you take the last term and you divide it by the second to last term. Then you take the second to last term and divide it by the third to last term. And then if you get the same number, you know that it's geometric. So let's look at that. 54 divided by 36. If you do that in your calculator, you'll get 1.5. And 36 divided by 24, if you do that in your calculator, you also get 1.5. Let's go ahead and do the last one. 24 divided by 16. Oh, that's also 1.5. So this is geometric because we have a common ratio, or something that we're multiplying by each time. Alright, let's look at the next one. Here we're going up, so we're either adding or multiplying by number greater than 1, or we're adding a positive number. So if we look here, 16 minus 9 is 7, 9 minus 4, let's write this down. 16 minus 9 is 7, 9 minus 4 is 5, 4 minus 1 is 3. That kind of looks like it has a pattern. We're subtracting by 3, 5, 7, or I guess we're adding by 3, 5, 7. So the next one would be 9, 11, or that's what we're adding by. But that's not a constant difference. So this is not arithmetic. Let's go ahead and try geometric. 16 divided by 9 is some random decimal. 9 divided by 4 is, let's see, 2.25. Okay, and 4 divided by 1 is 4. Now those are definitely not the same, so we know that it is not geometric. So this one would be neither. Okay, let's look at this last one. If we do 5 divided, or subtract 11, we will get negative 6. If we do 11 minus 17, we get negative 6. And 17 minus 23 is negative 6. So you can see that each time we're adding a negative 6 to get the next number. So if we added negative 6 to 5, our next term would be negative 1. So this is arithmetic. And we know that it's not geometric because if we were to divide 5 by 11, we would get 0.45 repeating. And if we were to divide 11 by 17, we would get this really gross number, 0.647, and then it keeps going on and on forever. And those are not the same numbers, so they're not equal. So it's not geometric. Here's an example where we know that the terms are arithmetic, and we want to find the common difference and then the next 3 terms for the sequence. Again, how to find the common difference, you're going to take the last number and subtract the second to last number from that. So if we do negative 28 minus a negative 17, we will get let's see, that doesn't help. Let's see, that's really a plus 17. So we will get negative 11. Okay, now let's do negative 17 minus a negative 6. That's really plus, so that gives us negative 11. And negative 6 minus 5 gives us negative 11. Okay, so our common difference is negative 11. That means that each time we are subtracting 11 from each term, or we're adding a negative 11. Okay, to our next 3 terms, we just take the negative 28 and we add negative 11. So that will give us negative 39. After that, that gives us negative 50. And then after that, that will give us negative 61. And those are our next 3 terms along with our common difference. If we look at the next one, 21 minus 19 gives us 2. Oh, nope, sorry, 3. And then 19 minus, oh, no, wait a minute. That is, oh, I see, I made a mistake on setting that up, because 21 minus 19 is 2. Okay, let's make that 22. There we go. So 22 minus 19 is 3. 19 minus 16 is 3. 16 minus 13 is 3. And 13 minus 10 is 3. So we know the common difference is 3. Now we just need to list the next three numbers. So if we add 3 to 22, we'll get 25. 25 plus 3 is 28, and 28 plus 3 is 31. This next example, we know that the sequences are geometric because it says to find a common ratio, and then we also want to find the next three terms in the sequence. So we are going to take the last number and divide it by the second to last number to figure out what our common ratio is. So we will go ahead and do 2 divided by 8, and that looks like it reduces to 1/4. If we do 8 divided by 32, that also reduces to 1/4. So our common ratio is 1/4. We're multiplying by 1/4 each time, or we're dividing by 4. So to get our next few terms, we are going to be multiplying by 1/4. When we do that, we'll get 2 times 1/4, which is 1/2. And then 1/2 times 1/4 gives us 1/8. And 1/8 times 1/4 gives us 1/32. And those are our three terms and also the common ratio. For the next one, again, we're going to take the last term and divide it by the second to last term. When we do that, we will get, 27 fourths divided by 9/2. When we are dividing fractions, we keep change flip. We keep the first term, change division to multiplication, and we flip the bottom number. So that is 2/9. Okay, when we multiply that through, it looks like the 4 can cancel with the 2, so we'll just get a 2 on the bottom. And this can cancel to be 3 with this one, which is 9, and that will cancel to 1, and this will cancel to 3. So we're left with, looks like, just 3/2. So let's double check that and make sure that's correct. Let's do 9/2 divided by 3. 3 is really over 1, so we'll have 9/2 times 1/3. And that will cancel with that to make that 3, so we also get 3/2. Alright, so our common ratio is 3/2. And to find the three new terms, we're going to be multiplying our last term by 3/2. When we do that, 27 times 3 is 81. 2 times 4 is 8. Okay, 81 times 3 is 243, and 8 times 2 is 16. 243 times 3 is 729, and 16 times 2 is 32. So those are our next three terms, and there is our common ratio.